So the time it's 1:49. So now is the last minute to submit the quiz. Okay, it means that next time we better check in the assignments. Sometimes it's not showing, it's not ringing. I think now it's already 1:50, so the quiz submissions is now closed. Okay, so today our lab is the lab number 2, pH, alkalinity, acidity, and the hardness. Alkalinity and acidity, it's not the same as the pH. pH is basically the measurements of the concentrations of the hydrogens, iron. Lab number 2. Okay, so pH is it kind of everybody knows that the pH is defined as the minus log concentrations of the hydrogens ion. So it's basically just the measurements of the hydrogens ion, or somebody may call it hydronium, but anyway, it's the minus log of the hydrogens ion. So it's not just the pH is divided. Sometimes if you pay attention on the concentrations of the hydroxide ion, you can use the term pOH. Or if you are interested in the equilibrium constant K, you can also define it K as the pK, as long as it is equal to minus log. Okay, so any value can be defined as the P, then concentration. So it's basically defined as the minus log. And we all know that pH is normally ranked from 0 to 14, from 0 to 14. Or on the other hand, we can say it like a pH plus pOH is equal to 14. Have you ever heard this term? pH plus pOH is equal to 14. Have you ever heard this term? In chemistry, I have. In chemistry, I think you know that the concentrations of the hydrogen ion plus the concentrations of the hydroxide ion, you would definitely get the 10 to the power of minus 14, so that the pH plus pOH is must be equal to 14. Just a moment. Okay, it's here. So now I'm showing what I'm showing on the screen is the OneNote applications. pOH plus pH is equal to 14. So this is the common terms. If you were doing chemistry very well in the secondary school, you will definitely remember this term. pH plus pOH is equal to 14. Okay, that is just the pH. Okay, but the pH is totally different from alkalinity and acidity. Alkalinity and acidity, it's for the alkalinity. So if the computer gets some heat, it is now not functions properly. Okay, so let's talk about the acidity first. Acidity, it's a kind of, on the other hand, we can say like we can define the acidity as the basis neutralization capacity. So basis neutralization capacity, it's the capacity to neutralize the bases. Okay, the capacities of water to neutralize the bases. In short, we can say it is the B and Z. Acidity is B and Z. B stand for the basis. N stand for neutralizations. C stand for capacity. So it's basically the capacities of water sample to neutralize the basis. On the other hand, for the alkalinity it's opposite to the acidity. So if the acidity is the basis neutralization capacity, so the alkalinity is the acid neutralization capacity. So this one is basis, this one is acid, okay? So in short, we can say ANC. ANC stand for acid neutralization capacities, okay? So these are the definitions of both acidity and alkalinity. So for acidity or alkalinity, how does it cause the acidity? The major cause of the acidity is the dissolve of carbon dioxide. So I'm talking about the natural water. So the dissolve of the carbon dioxide create the acidities in water. But sometimes the acids in water, the acids in water, it's not just because of the carbon dioxide. In some particular types of wastewater, like acid mine drainage. Acid mine drainage, it is the drainage. It is leaching water generated from the mining industry, especially the metal mining. So for the acid mine drainage, the leaching liquids normally contains significant amount of the strong acids or the hydrogens ion, so that the pH of the acid mine drainage normally goes very low, 1 or 2, like that. So it's even below 4 pH 4. So this is a kind of acidity is caused by the hydrogen ion. But if the pH is near 7, like a 6, or even slightly lower than that, 5, normally this kind of acid in water causes by the carbon dioxide. But just remember that I'm talking about the natural water, not wastewater contaminated with some acids due to the human activities. Okay, for the natural waters, the major cause of the acids is carbon dioxide, and some of the drainage from some activities like a mining. So this is the major cause of the acids. So why we have to be aware of the acids? The acids in water, even it's just the carbon dioxide, just the dissolve of the carbon dioxide, but they are still powerful to cause the corrosion in piping system, especially if we are going to use the galvanized steel pipe. You have to be aware of this problem. So the carbon dioxide dissolved in water is the major cause. Mineral acidity, it's the acidity caused by the hydrogen ion. The pH is very low. As I mentioned, it is caused it is caused by the drainage. You can find a lot of hydrogen ion in the drainage from mining industry, and the pH, if you measure, it would be like a 1 or 2 only. For the measurements, I will talk about it again later, but just move to the applications. So as I mentioned, the acid is associated with the corrosive characteristic of the pipe. So we have to be careful if we want to use the pipe for the long term. The water that supply that that is a supplier to the pike need to be the amount of acidity needs to be minimized. So this is the applications of the acidity informations. But anyway, the acidity is also play an important role, just like the alkalinity. So if the acidity is too high or too low, it may affect some chemical treatment process like coagulations and flocculation. Okay, and then for alkalinity, as I mentioned, by the definitions, alkalinity is the acid neutralization capacities, or ANC. So it's basically the natural buffer system. Do you know the buffer system caused by the weak acids and salts of weak acids, or the buffer system caused by the weak bases and salt of the bases? Have you ever heard about the buffer system in chemistry? มีใครเคยได้ยินมั้ง buffer system นะฮะ what is the definitions of the buffer system in the acid base? You have learned it. So the buffer is a kind of so if we are talking about the buffer due to the weak acids, so buffer due to the weak acids, what will happen if there is some acids or bases added? So if we keep adding some acids or bases, the buffer system will have a capacities to resist to the changes of the pH. So this is a kind of the a buffer system. So basically, buffer system is used to control the pH changes. Even in the water treatments, in some systems, we also prefer to have some certain amount of alkalinity just to resist the pH change. So if the due to the degradations of some organic substance. So basically, the acidities in nature, in the natures, mostly caused by the bicarbonate and the carbonate. But in some cases, the alkalinity in the nature caused by the bicarbonate and carbonate. But in some cases, the alkalinity may be caused by the hydroxides ion, the dissolve of the hydroxides ion. But mostly, we could find some bicarbonates in natural water, and they are both act as the natural buffer system to resist the pH change if there is some acid added accidentally or intentionally. But anyway, what are the beneficial use of the alkalinity and the acidity information? The alkalinities and the acidity information, as I mentioned, some of the chemical treatment process, especially the coagulation and flocculation, this process really depending on the pH or the acidities and alkalinities in water. It cannot, especially the additions of the of the alums. It really requires a pH in the neutral range. The acidities should not be higher, and alkalinity is also should not be higher. So it should be in the middle range. And in sometimes the degradations of the organic substance in the wastewater treatment, as we all know that if we keep the organic substance in the container, they tend to be degraded by the microorganisms, and once it gets degraded, the acids is formed. So finally, the solution contains a lot of acids inside. Just like the food, if we keep it outside without put it in the refrigerator, what will happen? In some hours after keeping outside, the food may turn to become more acidic, and you will smell some kind of acids, just like a milk. If you don't put it in the refrigerator, you keep it outside for some time, you will smell some acids. For example, if you left it overnight, tomorrow morning you check again, so it's all spoiled, and then there is the acids forming. So degradations of the organic substance usually tends to lower the pH. The acidity tends to increase. So this is the natural process that the alkalinities and acidities can be changed. So we need to know the alkalinity. The alkalinity is important in the chemical treatment process, chemical coagulation, as I mentioned, water softening. If you want to soften the water, reduce the amount of hardness in the water, you may have to pay attention on the pH and also the alkalinity. A corrosion control, alkalinity is the natural buffer system. If the water contains some certain amount of alkalinity, then we are sure that the corrosion can be prolonged. Like the pipe, if we can use it for just 2 years, then if the water contains some amount of the alkalinity, in that case, maybe we can prolong the corrosion time. Some sludge digestion. So we will talk about this again in the last chapter. Degradations of the organic matters will create a lot of acids. So in this case, we need the alkalinities. We need to maintain the alkalinity. So alkalinity is one of the parameters that we need to monitor during the sludge degradations. So in the last chapter, we will talk about the details of the sludge digestion again. Sometimes we need these information to control the reverse pollutions. So these are the beneficial use of the alkalinities and the acidities informations. Alkalinities and acidity is not really the parameters that we use to classify whether the surface water could be folded into class 1 or 2 or 3. So it's not the parameters that we use to classify the water quality, but we really need this information for the operations of water and wastewater treatment process. So it's the operating parameters, just like a pH. So pH we need to monitor all the times while doing the treatment. So similar to the alkalinities and the acidities, we also need to monitor all the times during the operations of the water and wastewater treatment plant. So the information showing in this slide is important. Okay, so you may go to this figure. This figure shows the acidity alkalinity associated with the pH scale. So the alkalinity, you can measure the alkalinity only when the pH of the water sample is above 4.5. Okay. You can measure the alkalinities only when the pH of the water sample is above 4.5. So less than 4.5, there is no alkalinity. Okay, so this is very important point. Below 4.5, there is no alkalinity. Above 4.5, there is the alkalinity. Okay, so if I give you the sample containing the pH 3, for example. So if you are given the water sample with the pH of about 3, and if I ask you to determine alkalinity and acidity, so you shouldn't give any value of the alkalinities, because in this case, the alkalinity cannot be measured. Okay, so less than pH less than 4.5, there is no alkalinity. But above 4.5, the alkalinity depends on the contents of the ion. Okay, so if the pH is in between 4.5 to 8.5, the alkalinity is mainly caused by the bicarbonate ion. But if it's above 8.3, if it's above 8.3, alkalinity may be caused by the combinations of the bicarbonate and the carbonate species. But if the pH is goes even higher than 10, the alkalinity may be caused by the hydroxide ion, like this. So basically, the alkalinity can be caused by many types of ion, but different type of ion gives different pH range to the sample. Okay, so this is very important information. So alkalinity essentially consists of two types. Type 1 we call the total alkalinity. The total alkalinity. So total alkalinity, if the pH of the sample, so it's in between 4.5 to 8.3, we can measure the total alkalinity. So if it's even ranking from 4.5 to 14, we can also measure the total alkalinity. But if the pH of the sample is just 8.3, above 8.3, you can also measure the phenolphthalein alkalinity. So phenolphthalein alkalinity is the alkalinity caused by the hydroxide ion, mainly caused by the hydroxide ion and some of the carbonate ion. Okay, but total alkalinity may be the alkalinity caused by several types of ion. Okay, so alkalinity essentially consists of two types: phenolphthalein alkalinities and the total alkalinity. There are two types of alkalinities. Okay. For the acidities and alkalinities, you will find they have a really close link to the pH scale. So same as the alkalinity, acidity also has the two types: total alkalinities, total acidities and the total and the mineral acidity. Okay, there are two types of the alkalinity. One is the total alkalinity, and another one is the mineral acidities or methyl orange acidities. Here is the pH scale I just used to describe the alkalinity and acidity. The pH scale ranked from 0 to 14. They are pH scale ranked from 0 to 14, and there are two markers at the pH 4.5 and the pH 8.3. At the pH 4.5, the marker that we use is the methyl orange indicator, and the pH 8.3, the markers that we use is the phenolphthalein indicator. For these two indicators, the colors will change. For the phenolphthalein indicator, if the pH is less than 8.3, these colors, the indicators, if we add it into the water sample, so it will show the color list. So if the pH is above 8.3, pink colors will appear. On the other hand, for the methyl orange, so if the pH is less than 4.5, so it will show a red color. So if the pH of the water sample is above 4.5, if we add this indicator, it will show the yellow color. So the transition, it's orange. Okay, so this is how these two indicators change the color. And these two indicators, as I just explained, we use these two indicators because they change the colors at the pH 4.5 and 8.3. Why we really focus on the why we really focus at the pH 4.5 or 8.3? Because below 4.5 there is no alkalinity. Above 8.3 there is only phenolphthalein alkalinity. That is why we pay attention at these two pH. Okay. There are two markers, 4.5 and 8.3. For 4.5, we use methyl orange just to observe the color. Phenolphthalein, we use the phenolphthalein indicators just to observe the colors while the pH changes. One sample, you can determine two of these parameters. For alkalinity, you can determine only when the pH is in between 4.5 to 14. But acidity, you can determine only when the pH is ranking from 0 to 8.3. So beyond 8.3, there is no acidity. Similar to alkalinity, below pH below 4.5, there is no alkalinity. Okay, but if the pH is above 8.3 at this point, you can find both total alkalinities and phenolphthalein alkalinity. So if you are going to find total alkalinity can be found when the pH is ranked from 4.5 to 14. So this one is the total alkalinity, and this one is the phenolphthalein alkalinities. So if the pH of the water sample is above 8.3, it means that the sample you can find both phenolphthalein alkalinity and the total alkalinity. But if the pH is approximately 7, it's somewhere around here, what you can find only total alkalinity. You cannot find phenolphthalein alkalinity. Okay. But for the acidity, you can find total acidity. Okay, for the sample containing the pH approximately 7 or in between 4.5 to 8.3. If the pH is below 4.5, you can find out the total acidity, and you can also find out the methyl orange or mineral acidity. Okay, so this is the link between the pH scale and acidity and alkalinity. Okay, these three parameters, they have a very close link with each other. For alkalinity, as I mentioned, the major cause of the alkalinity is the dissolve of the carbonate species. Carbonate species refers to the carbonate ion, bicarbonate ions, and another one is the hydroxide ion. So these three are the major cause of alkalinity in the nature. Alkalinity, on the other hand, refers to the acid neutralization capacity, as I mentioned earlier. For acidity is opposite to the alkalinity. So if the alkalinity is the acid neutralization capacity, so the acidity is the basic neutralization capacity. The major cause of the acidity is carbon dioxide, dissolve of the carbon dioxide. So it may exist in a form of CO2, or it may exist in a form of the hydrocarbonic acids. So this one is the carbonic acid, carbon dioxide associated with the hydrogen molecules. For the phenolphthalein alkalinities, you can find only when the pH is above 8.3, as I mentioned in the previous figure. For mineral alkalinity acidity, you can find only when the pH is linked from 0 to 4.5. So here are both highly basic and highly acidic. That's why I put a remark here. Water sample, in one water sample, you can measure at least 2 parameters. For example, if the pH is about 10, you can measure total alkalinity and phenolphthalein alkalinity. So if the pH is 6.5, so it's near 7, you can measure only total alkalinity and total acidity. But for the sample containing pH only 2, you can find out total acidity and mineral acidity. Okay, so in one water sample, I can say that there are two possible, there are two two parameters we can determine. The methods of analysis for the alkalinities and acidities, the method of analysis, we normally use the trimetric method, the trimetric method. Okay, so I will just come back to explain it again, the procedure. But for the alkalinity and acidity, there is one thing which is very interesting. The unit that we use to explain the alkalinity and acidity, the unit is milligrams per liter. Milligrams per liter as calcium carbonate. Where is it? Not this one.
อาจารย์ครับ
ครับ
คือผมควิซผมยังไม่ขึ้นเลยครับอาจารย์ทักไปหาอาจารย์แล้วอาจารย์ไม่ตอบผม
ควิซยังไม่ขึ้นเหรอฮะ
คือมันยังไม่ขึ้นใน assignment เลยอะครับแบบไม่มี assignment นะใน assignment เลยอะครับ
เหรอ or maybe you are not our member you are guest
ผมเป็นแล้วนะครับเพราะว่าควิซแรกผมก็ควิซไปแล้วแต่ควิซ2มันไม่ขึ้นให้ผมอะครับ
เหรอ
ครับ
วันนี้มีอาการแปลกๆในเรื่องของควิซหลากหลายรูปแบบนะฮะ
ผมส่งไปให้ดูในแชทอาจารย์แล้วครับ
เหรอฮะครับ
อาจารย์ค่ะของหนูก็เพิ่งขึ้นตะกี้เลยอะค่ะควิซ2ที่ให้ส่งตอน13:50อะค่ะเพิ่งขึ้นว่าควิซ2อะไรอย่างเงี้ยค่ะ
ไม่แสดงว่าวันนี้ผมว่ามันมีอะไรแปลกๆทุกทีผมก็ใช้อยู่ก็ไม่เห็นมันเป็นอันใดแสดงว่าอาจจะเป็นที่ไม่ก็ connection หรือไม่ก็ MS Team ไม่ก็ที่ application นะฮะแต่ว่า connection ก็อาจจะเป็นไปได้นะเพราะว่ามันก็บางที่ก็อาจจะเร็วช้าดีเลย์กันไปส่วนMS Team ก็อาจจะเป็นไปได้เหมือนกันไม่แน่ใจว่าเรื่องของสาเหตุเดี๋ยวเราเช็คกันอีกทีนึงแล้วกันสำหรับควิซในวันนี้นะฮะOkay, just come back to the alkalinity and acidities again. What อะไรฮะ
ถามนิดนึงครับผมถามนิดนึงครับอาจารย์ครับคือตอนนี้เราวัดอยู่2ที่ก็คือไอ้ตัว 4.5 แล้วก็ 8.3 ใช่ไหมครับ
ใช่ฮะใช่
ก็คือถ้าสมมติต่ำกว่า 4.5 มันจะ
ไม่เป็น 4.5 no alkalinity คือ less than 4.5 no alkalinity on the other hand above 8.3 no acidity okay above 8.3 no above 8.3 no acidity
okay ครับ
just like this one so this is the pH scale ranking from 0 to 14 less than 4.5 no alkalinity above 8.3 no acidity ฟังให้ดีนะเพราะว่ามันจะตรงกันข้ามกันเสมอนะฮะokay so for these parameters there is one thing which is very interesting and there is one question I asked in the quiz what is the unit of alkalinity and what is the unit of the acidity the unit of the alkalinity and the unit of acidity are the milligram per liter as calcium carbonate have you ever wondered why they like this why the unit is like this as calcium carbonate. Have you ever wondered about this? Milligram per liter as calcium carbonate. Why they don't use the milligram per liter? Why? That is the question. So to answer to these questions, you have to have a look at the major cause of the alkalinity. What are the major causes of the alkalinity in the water sample? The major cause of the alkalinity are it's basically the alkalinity in the water sample is basically caused by maybe this one, hydroxide ion, or a carbonate ion, or a bicarbonate ion. So these three ions can actually cause the alkalinity. Similar to the acidity, the major cause of the acidity is the dissolve of carbon dioxide, which may exist in the carbon dioxide itself or may exist in terms of the carbonic acids. So in this case, if you say like a milligram per liter, it's a milligrams of what? Okay, for hydroxide ion, so if it's like a milligrams per liter, so if you can measure the hydroxide ion and then you get the value A milligrams per liter, and if you measure carbonate ion, you get B milligrams per liter, and finally if you measure the bicarbonate ion, you'll get C milligrams per liter. So they are all reported in terms of the milligrams per liter. But if I ask you what is the value of alkalinity measured from this sample, of course, it's not equal to A plus B plus C. Do you know why? Alkalinity is not equal to A plus B plus C. The thing is, A milligrams per liter, it's milligram with respect to A. B milligrams per liter, it's also milligrams with respect to B. This one, milligrams per liter, it's a milligrams with respect to C. So they are not the same, okay? They are not the same unit. So we need to convert this into the same unit. And with respect to something, the things which we normally used to refer to is the carbonate, calcium carbonate. So we convert this one into milligrams per liter as A, milligrams per liter as B, and milligram per liter as a C. We convert these three types of units into one unit, and it becomes a 1 milligrams per liter as calcium carbonate. So how do we convert it? This one converted from this unit into this unit. How can we do that? Okay, just have a look here again, another example. So this is water sample. This is the water sample. So I'm now on the OneNote page. Okay, so you should with my OneNote applications on the screen. You should be with my OneNote applications on the screen. Okay. If you are not, just tell me. I think I have already shared the screen. Okay. Okay. Here is the water sample. Okay. Here is the water sample. So if this sample essentially contains ammonia, 5 milligrams per liter, and also nitrates, another 5 milligrams per liter. If I ask you what is the total nitrogens in this sample? So if I ask you what is the total nitrogens in this sample, so of course it does not equal to 10 or 5 plus 5, because 5 milligrams per liter, it's milligram with respect to the ammonia. This one, 5 milligrams per liter, it's also 5 milligrams with respect to the nitrate. So you cannot say like a total nitrogens is equal to 10 milligrams per liter. Different unit cannot be combined. So this is very common. Okay, different unit you cannot combine. Okay, if you want to convert this different unit into the same unit, so how you can do it? So if I want the answers in terms of milligrams per liter as n, milligram per liter with respect to the nitrogens, so you have to convert these two units into the milligrams per liter as the nitrogens, or with respect to the nitrogens. So in this case, what we can do for ammonia, NH3. So if you want to convert milligrams per liter as ammonia to the milligram per liter as N, so you can just use the concepts of mole, molarity. So 5 milligrams. So if you want to convert this one into a mole, you have to divide it by the molecular weight. You have to divide this amount by the molecular weight. Grams divided by molecular weight is mole. Okay. So if you divide this one, molecular weight of the ammonia is 17. 5 divided by 17. This is mole, probably millimole, because here is the milligrams. Okay. Then if you want to convert it into the nitrogens, so you have to multiply this one again with the molecular weight of the nitrogens, 14 moles multiplied by the molecular weight, another molecular weight. So you can convert it into the mass with respect to the molecular weight you are interested. So this is a kind of a conversion procedure. So basically divided by the molecular weight of this one, multiplied by the molecular weight we want to convert it to. For the nitrates, the concentration is 5 milligrams. So if you want to express in terms of milligram as N, so you have to divide it by the molecular weight of nitrates and then multiply by the molecular weight of nitrogens. So this one, if you get X milligrams as N, this one, if you get Y milligrams as N, only these two values you can combine and report it as the total nitrogens. Okay, so this is how we convert the unit, and this is probably the reason why we prefer to use this unit to define the amount of alkalinity and acidity in water. Okay, so the unit of alkalinity and acidity is milligram per liter as calcium carbonate. The same as the hardness we are going to talk about again. So milligram per hardness is also expressed in terms of milligram per liter as calcium carbonate, because the major cause of the hardness is also due to the carbonate species. Okay, so these are the procedure or why we have to convert this into the same unit, because the major cause of the these parameters are probably due to various species. Okay, so this is the theory about the background information about the alkalinity and acidities. And talking about the hardness, this information I have put it in the files, so you may have a look again later. So for the hardness, hardness is normally defined as the summations of the polyvalent cation. The hardness is defined as the summations of the polyvalent cation. For example, calciums and magnesiums, hardness in the nature mostly caused by these two positive charge ion. Others may cause the hardness, but not in a significant amount. So hardness in the natural water mainly caused by these two calciums and magnesiums. So how the calciums and magnesiums get into the water? In the groundwater, it's kept in the aquifer in the soil. So this is the ground, and this is the topsoil layer. This is the layer where there is a bacterial activity. Microorganisms live here and degrade some organic substance. During the degradations, there is the respirations, and the products of the respirations is the carbon dioxide, just like we exhale the carbon dioxide while we have the respiratory respirations. So this one, carbon dioxide may get accumulated in the pore near the topsoils, and if there is a rainwater gets seepage through the grounds, and then carbon dioxide may interact with water and get dissolved and becomes a carbonic acid, and water becomes more acidic. So acidic water, once it moves down and reach the limestone layer, so this acidic water could actually leach this limestone. Calciums and magnesiums get leached out, becomes the calcium ion, magnesium ion, probably sodium ion. So this ion get dissolved in water and stay as a part of the contaminants in the groundwater, as well as the negative charge ion like carbonate and bicarbonate, and some other negative charge ion. So we can define it like this for the total hardness. So for the total hardness, as the major cause of the hardness in terms of the positive charge ion, so the major cause of the hardness is the calciums and magnesiums. So in general, we can say in terms of the positive charge ion, hardness is equal to calcium hardness plus the magnesium hardness. Okay, calcium hardness plus the magnesium hardness. Calcium hardness, what does it mean? It means calcium ion associated with some other negative charge ion, for example, bicarbonate, carbonate, or maybe chloride, or maybe sulfate. Magnesium hardness is the magnesium associated with other negative charge ion, bicarbonate, sulfate, and some other. Then, on the other hand, if we only focus on the negative charge, the hardness can be classified as the carbonate hardness and non-carbonate hardness. What does it mean by the carbonate hardness? Carbonate hardness means calcium or magnesium associated with these two species, bicarbonate and carbonate. In general, we say this one is the carbonate species. So if calciums and magnesiums associated with the carbonate species, we can say that this hardness is the carbonate hardness. But if they are associated with some other anion, for example, sulfate and chloride, so this one we call them as a non-carbonate hardness. Non-carbonate hardness. Okay, so we have a carbonate hardness and non-carbonate hardness. If we classify it based on negative charge ion or anion. Have you ever heard about the permanent hardness or temporary hardness? Permanent hardness and temporary hardness. Have you ever heard about it? Temporary hardness, what does it mean? Temporary hardness. So it's basically the hardness which can be removed by boiling, right? The temporary hardness is the hardness which can be removed by boiling. So if you boil the hard water, hardness will precipitate it and stick it to the bottoms of the pot, becomes a scum, a scale, sorry, not scum, scale, okay, becomes a scale at the bottoms of the pot. So this is the carbonate hardness or the temporary hardness. Temporary hardness and carbonate hardness are the same. They are they can be removed easily by just boil the water. But if you boil the water, but the hardness is still there in the water, not precipitated as the scale. That hardness is normally called the permanent hardness or non-carbonate hardness. Okay, carbonate hardness is the temporary hardness. Non-carbonate hardness is the permanent hardness.โอเคภาษาไทยเราเรียกว่าอะไรความกระด้างชั่วคราวกับความกระด้างถาวรชั่วคราวก็คือ carbonate hardness นะฮะ carbonate hardness it's a temporary hardness okay in the lab what you can measure in the labs you can measure the total hardness you can measure the total hardness you can also measure the carbonate hardness you can measure the carbonate hardness you can measure the total hardness you can measure the carbonate hardness and if you know these two values you can find out magnesium's hardness because both the hardness the units are milligrams per liter as calcium carbonate so they are the same unit the units are same so we can compare and then we can find out magnesium hardness easily because this magnesium's hardness is equal to total hardness minus calcium's hardness okay so this is how we determine the magnesium's hardness and for the total hardness we know this value we can determine it from the labs and what if you want to find out the carbonate hardness and non-carbonate hardness the total hardness can be determined by using the trigonometric method total hardness we can do it by trigonometric method but for the carbonate and non-carbonate we cannot measure it directly but one thing we know is carbonate hardness is the hardness caused by the carbonate species and the carbonate species is actually somebody's microphone is on microphone ใคร switch on หรือเปล่า Can you just check again ธัญชนเดี๋ยวนะokay carbonate hardness cannot be measured directly but one thing we know is the carbonate hardness is the hardness caused by the carbonate species and combination is these two it's on the other hand has a very close link with the this carbonate species has really close link with the alkalinity measurements so for the carbonate hardness we will not measure these two directly but we measure alkalinity instead okay so we check the alkalinities and we make use the alkalinities informations and we can use alkalinities information to evaluate the carbonate hardness so it means that we still can determine the carbonate hardness but we don't measure directly we measure the alkalinity instead okay so this one total hardness we can determine from the labs alkalinity we can also determine it from the labs then we just we just take this one minus this one then we will get the non-carbonate hardness so finally all 6 parameters we can find out okay here okay so these are the backgrounds information about the hardness and then and then for the hardness where are we now okay for the hardness is the parameters which is quite strong as compared to the other parameters for other parameters pollutants and contaminants we try to remove them all turbidity in terms of the water purifications we need to remove them from water so we need zero turbidity we need zero color for drinking water but for the drinking water or the tapped water zero hardness is not necessary. So if you want the zero hardness, you will get the soft water, extremely soft water. So what will happen to the extremely soft water? You will not feel comfortable to use that water for the consumptions, especially for the during taking a shower. So if you take a shower with the soft water, I'm sure that you will not feel comfortable because a lot of soap, very difficult to wash out because soft water does not react with the salt, but hard water somehow react with the soap, so you will enjoy taking a shower. So for the hardness, we prefer to have the hardness in the moderately hard range. So hardness in tapped water should be in the range of 75 to 150 milligrams per liter as calcium carbonate. So we are not expected to get a zero hardness, but this range, moderately hard range, is the most appropriate range for potable water. So for groundwater, this morning I show you the table comparisons between groundwater and surface water, groundwater and surface water. So if you still remember, the hardness in the groundwater goes up to 400 milligrams per liter as calcium carbonate. So in that case, we have to bring them down to be at least below 150. But for the surface water, you can make normally the hardness in the surface water it's around 100 to 250. So for surface water, you don't have to do anything with the hardness. So there's no need to apply a softening process to the surface water if you use the surface water as the water supply source. So hardness, we basically just want to maintain in this range. So if it is already in this range, then we don't have to do anything with hardness. But if it is too high, then we have to soften the water. So this is the goal of treatment. We are not aiming to get a zero hardness or a hardness-free water, okay? But we just want the moderately hard water for consumptions, okay? So these are the backgrounds about the hardness and the alkalinities and acidities. But anyway, for the hardness, we will talk about this in the details again in chapter 7, chapter 6 maybe, in the lectures. But today is just a brief introductions so that you understand the major cause of the hardness and then what are the significance why the hardness is a significance, hardness information is a significance to the water engineers. Okay, so these are the backgrounds of the these three parameters. So alkalinity and acidity have really close link with the pH. Hardness, we reported the same unit as the alkalinity and acidity. So the unit of these three parameters is the milligram per liter of as calcium carbonate. Okay, so these are the three, the unit of the three parameters. So why we have to use this unit, milligrams per liter as calcium carbonate? We have to use this unit because the major cause of alkalinity, acidities, and hardness are the carbonate species. So several types of ion cause these three parameters. That is why in order to make it more meaningful, so we convert the unit into milligrams per liter as calcium carbonate with respect to something present in water. So the most abundant iron present in water, it's carbonate. That is why we normally refer to calcium carbonate to report the value. Okay, so these are the what I was trying to give you some background. Then for the procedure, to analyze the alkalinity and acidity, you may go to the files. So in the files, somebody has posted some message. Okay, so it just come the quiz just showing on that screen. I don't know what's wrong with the connections or the applications itself. Okay, so just come to the files. You will find the class, the information in the class material background. I have already put all these informations in here. The hardness and then the brief introductions about the hardness, same as the alkalinity and acidity. So these two files will be very useful for you. Then for the procedure, pH, alkalinity, and acidity. Something new just. Huh? Another quiz? Something strange to my computers today. Okay, for the protocol, inside this protocol, you can have a look at this file, pH, acidities, and alkalinities. So the samples you will get today, you will get 3 samples, the same as the previous week, tapped water, surface water, and wastewater. So each samples in the in the actual, in the normal session, you will have to analyze at least, these 3 parameters. For the acidity, how do we measure the acidities? Acidities, in order to determine acidities, you have to titrate against the best. The best that we use as the tritant, we normally use the sodium hydroxide. The concentration is 0.02 normal. 0.02 normal. Have you ever heard this unit normal? เคยได้ยินไหมฮะ normal มีใครเคยได้ยินมั้ยคำว่า normal normality เคยได้ยินไหมฮะ
เป็นกลางเนี่ยครับ
no รู้จัก molarity ไหม molarity รู้จักไหมฮะ
เคยได้ยินครับ
molarity นี่คือในเคมีนะฮะเป็น concentration so it's basically grams of the chemical agents divided by the molecular weight. So that is molarity. But for the normality, so it's the grams of the chemical agents divided by the equivalent weight. Have you ever heard about the equivalent weight? Equivalent weight.เอ้วันนี้มีความแปลกในแง่ของแอปพลิเคชันอุปกรณ์หลายอย่างเลยมันไม่レスปอนส์ทันทีทันใดนะ equivalent weight EW molecular weight is molar is a grams divided by molecular weight and then you dissolve it in 1 liters that is molar but equivalent weight is actually grams divided by EW in 1 liters. So what is EW? This is normality, sorry. This is normality. This one is molarity. So I think everybody familiar with this one. So 1 molar of sodium hydroxide. So you have to weigh the sodium hydroxide, how many grams. So if you want to prepare 1 molar solutions, so if you want to prepare 1 molar sodium hydroxide solution, so how many grams of the sodium hydroxide you have to take it and dissolve in 1 liter of distilled water. So how many grams of sodium hydroxide if you want to prepare the solutions containing 1 molar of sodium hydroxide? So how many grams of hydroxide you have to take? This is the basic chemistry. กี่กรัมฮะ Sodium, the molecular weight is 23. This one is a 16, and this one is just 1. So how much is it?
1 ส่วนในนั้นบวกกัน
40. Molecular weight is 40, right? 40 grams ใช่ไหม molecular weight คือเท่านี้ใช่ไหมเพราะฉะนั้นเนี่ยmolecular weight เนี่ยถ้า1โมลาร์คุณต้องชั่งมากี่กรัมถ้า1โมลาร์ก็ต้อง40 กรัมถูกไหมฮะเพราะว่า molecular weight ของsodium hydroxide ก็คือ40 กรัมเพราะฉะนั้น you have to weigh 40 grams of the sodium hydroxide and dissolve it in 1 liter of distilled water. So only this you will get the solution containing 1 molar of the sodium hydroxide. What about 0.1 molar sodium hydroxide? So how many grams of sodium hydroxide you have to weigh? 4 grams, right? So how about 2 molar of sodium hydroxide? How many grams of the sodium hydroxide you have to weigh and then put it in 1 liter of distilled water? 2 molar. So you have to take like เท่าไหร่ฮะ80 grams of sodium hydroxide. Like, so this is how you measure, you prepare sodium hydroxide sample. But anyway, sodium hydroxide solutions. But anyway, that is chemistry. But here I just want to explain normality is something different from molarity. This one, instead of divided by the molecular weight, but normality are divided by equivalent weight. So what is the equivalent weight? Equivalent weight is the weight, but it's equal to molecular weight divided by number. So what is the number? I can say like if the calcium carbonate. So what is the molecular weight of calcium carbonate? So this one is 40. So this one is 12, and this one is 16 into 3 is 48. So molecular weight of calcium carbonate is 100. Okay. But if I ask you, what is the equivalent weight of the calcium carbonate? Equivalent weight of calcium carbonate is equal to 100 divided by 2. 2 is the number. So how does it come? 2. It's divided by 2, and then equivalent weight is equal to 50. Why we have to divide it by 2? If you consider this one, calcium, once it dissociated, so it becomes a calcium plus 2, and carbonates minus 2, right? So 2 charge exchange with each other. So we divide it by 2 because in case of calcium carbonate, 2 charge exchange with each other, positive and negative, positive or negative. So we have to divide it by 2. Then the equivalent weight becomes 50. So the number that we divided means the number of the charge exchange in this case. But if I'm talking about the carbon dioxide get dissolved in water, becomes H2CO3, right? So this is the carbonic acid. Everybody knows that very well, carbonic acid. So carbon dioxide. So what is the molecular weight of carbon dioxide? This one is 12. This one is 32, right? Oxygen is 32. 16 into 2 is 32. So molecular weight of carbon dioxide is 44. And what about the equivalent weight? Equivalent weight of carbon dioxide is equal to 44 divided by the number. So this number is 2. Why it has to be 2 again? So in case of the acids and base equilibriums, so it depends on how many protons dissociated. So this one, how many protons involved in the dissociation of the carbon dioxide? 2, right? 2, H2. So that is why we divided by 2. Then the equivalent weight of carbon dioxide is 44 divided by 2. So it becomes 22. So this is how we obtained the equivalent weight. So what is the equivalent weight? Equivalent weight is equal to molecular weight divided by the number. So in case of the dissociations, in case of the interactions, oxidation, reduction, so this number refers to the charge exchange. In case of the acid-base equilibriums, so the number is the protons exchange like that. So it depends on the reaction. But anyway, equivalent weight is something different from molecular weight. Okay, that is why in here you will find the concentration is expressed in terms of 0.02 N. N is the normality. N is the normality. Okay, not molality. Normality. Okay, so if you have time, you may look into the details again, the definitions of the normality. But I think the normalities you have studied intensively in chemistry. I'm not sure in the first year chemistry you have to take this course, and I think somehow they already mentioned about this. Okay, so if you want to measure the mineral acidities or total acidities, you have to titrate against base, and the base that we use is the 0.02 N NaOH. Acidities, we use the NaOH. Both total acidities and mineral acidities, we use the here we put the sodium hydroxide. Okay, here we put the sodium hydroxide. For mineral acidities, the indicators that we added, we use the methyl orange indicators. These indicators, they actually change the pH at around 4.5, in fact 4.3 to 4.5. Okay. For the total acidities, with the tritant is the same as the mineral acidities, but the indicator is just different. The indicators, we use the phenolphthalein. Okay, we use the phenolphtaleins, and then we titrate until a faint pink first appear. Okay, so for the acidity, just have a look at the scale, the pH scale, ranking from 0 to 14. Acidities can be measured only if the water sample has the pH ranking from 0 to 8.3. Above 8.3, there is no acidity. Okay, for the alkalinity, also the same, but just opposite to the acidity. Here, if you want to find the total alkalinity, you have to titrate against acid. หาด่าง titrate กับกรด หากรด titrate กับด่าง Okay. For the total alkalinity, you have to use the methyl orange as the indicator. Okay, you have to use the methyl orange as the indicator. Prepare the sample 50 ml and then add a few drops of the methyl orange indicator. And once everything is ready, just try it against the acid, and then record the number, the volumes used. After you get the volumes of acids used, then you have to calculate. You have to determine the total alkalinity. The titrations will not give you a value, but it will just give the volumes of acid consumed. But you have to calculate. The total alkalinity is equal to the mLs of the tritons consumed into 1000 and divided by ml of the sample. The same as the acidity. Finally, you have to record the amount of the tritrans, then take it into considerations and calculate. Phenolphthalein alkalinities. Phenolphthalein alkalinities will be there only if the sample contains the pH above 8.3. Okay, if the samples contains the pH above 8.3, only this you can file the phenolphthalein alkalinity. The phenolphthalein alkalinity is the same. We tried it against the acid. We do the titrations against the acids. Then we used a few drops of the phenolphthalein indicator. The colors will changes from until the pink first disappearing. Okay, so this is the this is the scale of the pH, and this you can have a look again. So if the pH is around 6.5, what you can find is only acidity and alkalinity. Sorry, total acidity and total alkalinity. But if your pH scale is just 2, the things that you can find only mineral acidities and total acidity. Okay, minerals and total. Okay, so these are the procedures how we measure the alkalinities and acidities. And the last one is the measurements of the hardness. Okay, maybe I will just use these files again. For the total hardness, procedures are very similar to the alkalinities and acidities determinations, but there are some certain few more steps as compared to the alkalinities and acidity. In here, we still used 50 ml sample, then add 1 to 2 ml of the buffer solution. So it's ammonium buffer. Then add Eriochrome back 3. So this one is the name of the indicator. And then titrate against 0.01 molar EDTA, ethylene diamine tetraacetic acid. Okay, so then we record. The color should actually change from purple to blue. So once it turns blue, so that indicates the endpoint. Okay. The same as the calcium hardness. The calcium's hardness, we use the Murex size as the indicators, but other things are also similar. Okay, first we need to add 50 ml of the sample, then 1 to 2 ml of the sodium hydroxide, 1 normal sodium hydroxide, and then we add the calcium indicator. So this calcium indicators, we add just 0.1 or 0.2 grams. So just very small amount. Then again, we titrate against the 0.01 EDTA. So this one is similar to this one. So the tritangle for these two cases are the same. Okay, calcium hardness and the magnesium hardness. But the thing which are different in between these two analysis is for the total hardness, we use the buffer instead of sodium hydroxide. And for the indicator, total hardness, we use the ideochrome Bacti. But for the calcium hardness, we use the murex size instead. So these are the procedure we use to measure the hardness. And as I mentioned, carbonate hardness, we cannot measure it directly. The only thing we can determine is we can measure the alkalinity of the water sample. And alkalinity, the major cause of the alkalinity is the carbonates species, bicarbonates and carbonates. So if you measure the alkalinities, there are two possible cases if you compare with the total hardness. The first case, if the alkalinity is greater than the total hardness, pH stands for the total hardness, okay? So if the total hardness is less than the alkalinity, so in this case, we can say, in this case, we can assume if the alkalinity is greater than the total hardness, in this case, we can assume the total hardness or the total hardness are the carbonate hardness, no non-carbonate hardness. Okay, no non-carbonate hardness. But another case, if the alkalinity is less than total hardness, we can say that carbonate hardness, we can assume carbonate hardness is equal to the alkalinity. Then non-carbonate hardness is equal to total hardness minus carbonate hardness. So at the end, you are expected to write the bar chart. So this bar chart should essentially contain like this. This is the example for the case 1. Calcium hardness, magnesium hardness is here. So you put the amounts here. Then you compare with the alkalinity. So if the alkalinity is less than total hardness, we can assume alkalinity is the carbonate hardness, and the remaining part is the non-carbonate hardness. That is the first case. Second case, if the alkalinity is greater than the total hardness. So in this case, we can assume it, all the hardness present in this water sample is carbonate hardness, no non-carbonate hardness. The second case, okay, it's in the second case. Okay, so these are the two possible results that you may have obtained from the analysis. Okay, so these are all the methodologies for the alkalinity, hardness, and acidity. So these are 3 parameters. Is there anything I need to show you in this presentation? So this is also the procedure, total acidity. Okay, another thing which is very important, reading the Biuret scale. So the Biuret that we used in the labs, at the top, you will find the scale 0, and here at the lower part, you will find scale 50. So basically, the Biuret, you can put 50 ml of the tritrand. And rating the Biuret scale, you should take a look at the bottoms of the scale. So only with that you can read the scales. I think this skill you have you already have chance to practice in the chemistry labs when you study the first year. As the first year students, you have already practiced using and reading the scale from the Biuret. Any other things? Okay, so there are some procedure. So these presentations, I think I haven't put it in the files, so I'll put it later. So here you can find once you added the electron back T as the indicators, it should turn from purple to blue. But if it's already turned blue, it means that there is no hardness. Calcium hardness the indicators that we used is the Murex size. So here the indicators are totally different from the acidities and alkalinities, because acidity and alkalinities, the indicator is the solution. So we just add a few drops. But in here, the indicator is a powder indicators. So we just take just only 0.1 to 0.2 grams. We don't have to, wedge this small amount, but just approximate wedge and just take the approximate 0.1 to 0.2 grams and put it directly. So we don't have to wedge them. We don't have to wedge exactly 0.1 or 0.2 grams. So that's not significant if you wedge or you don't wedge. Okay, so the endpoints we show if the pink turn to the light purple like this. Okay, so that is all for the procedure. Then let's have a look again for the results that you will get. I assume you all get the assignments ได้หรือยังฮะผลresults today's labs results. Have you already got this results ได้หรือยังครับ
เหมือนจะยังไม่ได้เลยครับ
ยังอีกเหรอนะฮะ
ผมได้แล้วครับ
ได้แล้วนะ so just again check the assignments, just check in the assignments. So this today yesterday I was checking the register office. We are now the students who take this course is now there are 27 students, so I have divided into 4 groups. So each group contains how many members? 7 members. Okay, so each group contains 7 members. Then okay, so this is something else. So you should get the same types of results within the groups, but each group will get the different results. Okay. Where is it? Lab 2. So if you are not getting, so just check again. Siddhipon, you have already viewed, right? But Napasakorn, Piti Chai, Vachalakrit still not turned it in. Okay, just check again. So in case if you don't get it, just leave the message. Okay. Okay, for the results. So how the results will look like? So each group we need to do 3 samples, the same as previous week. The first one is the surface water. The surface water. The first sample. We do the acidity treated against 0.2 normal sodium hydroxide and use the phenolphthalein as the indicator. The bill rate that we have rated. So the starting point is 0.8 until the end points. So at the end points, the students stop the titrations and take a look at the bill rate. Then the end rate is 0.3 ml. It's a 0.3. So if you want to take this, this is the raw data you obtained from the lab. So it will be something like this. So you have to record start and end. Again, repeated 3 times. So the second time is starting from 1.3 and finish at 1.7, and the last sample starting from 1.7 and then finish at 2.2. So if you want to know the volumes of this triton used, so you have to take this one subtracted by this one. So this one subtracted by this one is 0.5. Okay, so 0.5 ml is used to react with some contaminants in water sample. Okay, so basically we do 3 replicates. So this each replicates you get this raw data, and this raw data you determine the acidities, and finally you have to take the average of these 3. The average acidities information of these 3 and then report it. So the first one, you determine the acidity. The results you obtained from the second trial, then you determine the acidity. The results you obtained from the third trial, then you determine the acidity. So you have 3 acidities value, then you take the average. Okay, then you will take the average. So once you take the average, you will get only one value as acidities of this sample. Acidities of each sample, alkalinities of each sample, there are only 1, not 3. Okay, so you have to take the average. Okay, then the hardness. Alkalinity is also the same. Then the hardness. We determine the total hardness, and then again the calcium hardness. So 3 replicates with the 3 replicates, and at the end we can get these 2 informations. And finally, if you want to determine the carbonate hardness, then you have to take the alkalinity informations and then measure the hardness. Surface water, 3 or 4 parameters are given. Taps water, 3 or 4 parameters are given. But in a wastewater, we don't do the hardness, because hardness is not the parameters that we are interested. So we never measure the hardness in case of the wastewater. So for wastewater, we don't do the hardness. That is why here we are not showing, you are not getting the results concerning the hardness in wastewater. So wastewater, we just do the acidities and alkalinities. Okay, so these are the results. How you will you can take these results and then prepare the lab report. So I would expect that you will present these results in a meaningful tabulate forms. Okay, so these are the informations you are expected. If you do it in the labs, you will get these types of results. Okay. Do you have any questions regarding to this labs results? Do you have any question? Until now, you may not have a question, but once you start preparing the reports, you may have some questions. Okay. มีคำถามไหมฮะ
อาจารย์ครับ lab ที่เป็น acidity alkalinity นี่กับตัว hardness เรารวมเป็น lab
รวมเป็นอันเดียวเลย รวมเป็น lab เดียวเลยครับ เพราะว่า เพราะว่าจะต้องใช้resource ชุดเดียวกันนะคือถ้าจะหา hardness carbonate hardness คุณก็ต้องเอา alkalinity ไปใช้นะฮะนึกออกไหมฮะเพราะฉะนั้นเป็นหลักเดียวกันไปเลยแต่ว่าต้อง present ด้วยกันนะครับนะฮะโอเค do you have any question any more question related to this today's lab's results no okay so again for the groups I'm not sure in your MS team you get the assignments do you know who you are supposed to work with รู้ไหมครับตอนที่มันส่งไปเนี่ยมันส่งไปกับใครคนอื่นบ้างหรือเปล่าคุณมองเห็นคนอื่นด้วยหรือเปล่า for example
มองไม่
ผมเห็น
ค่ะ
แค่
จะ
ผม
รู้
เองครับ
ในไลฟ์สไตล์ค่ะ
อะไรนะฮะอะไรนะครับอย่างกรณีของอะไรเนี่ยปิติชัยเนี่ยคุณรู้ไหมว่าคุณassignment ที่คุณได้รับเนี่ยมันเป็น member เดียวกันกับ others like สิทธิพลนภัสกรเนี่ยใน in your system does it show no
ถ้าใน Microsoft Teams ไม่เห็นนะคะอาจารย์จะรู้เพราะว่าอาจารย์เคยให้รายชื่อ
โอเคokay here I have revised the group's member because there are some student who has just enrolled who has just registered just a moment so everything seems to be very slow today
อาจารย์ครับกรุ๊ป1ยังไม่ได้ผลแลบเลยครับ
ยังไม่ได้เลยเหรอ
ครับยังไม่ได้ครับ
เดี๋ยวนะnumber one run ใช่ไหมชื่อว่า run ใช่ไหมอยู่ในนี้หรือเปล่าเนี่ย run เนี่ยเศรษฐโรจน์นะฮะstarting from run to พิชยะนะฮะyou haven't get any assignments can you just check again
ดูให้นะครับอาจารย์
other member can you just check again because sometimes it gets delayed
เพราะผมยังไม่ขึ้นเลยครับแต่ผมว่าเซิร์ฟมันน่าจะแหลกๆหรอครับอาจารย์
it is possible okay and then the group number 2 started from อะไรเนี่ยนภัสกรลักษิกาปิติชัยชัยกฤษสิทธิพลธนพลวัชรฤทธิ์นะฮะand group 3นะฮะวริศราหารุณะนะฮะธัญชนวัชรพลณัฐพัฒน์พิชพัฒน์พานุพงศ์นะครับ and then the last group 4 this is special there are only 6 members พบพจน์สัญญพงศ์สิมิลันควรชยกฤษ and the last one is สาริยา so you're supposed to get it very soon I think that's
อาจารย์
ครับ
ขอโทษนะครับชื่อผมยังไม่ขึ้นนะครับผมเพิ่งลงทะเบียนไป
อะไรนะฮะ What is your
ชื่อ
name
ผม
again
ยังไม่ขึ้นนะครับ
ชื่ออะไร
กฤษตันครับเบอร์26อะครับ
เดี๋ยวนะพานุพงศ์นี่มันเบอร์21ใช่ไหม
อาจารย์น่าจะลืมเอาสุกิจเข้าไปไว้ในกลุ่มอะค่ะ
สุกฤต
ครับผม
มีสุกฤตคนเดียวใช่ไหมฮะที่หายไป
น่าใช่นะครับ เพราะว่า ใช่ครับ มีแค่สุกิจคนเดียวครับ
สุกฤตใช่ไหมฮะ เอ๊ะทำไมไอ้ตัวเลขมันแปลกๆ มีตัวเลขอะไรซ้ำหรือเปล่า สุกฤตน่าจะถูกยัดเข้าไปในกลุ่มที่ 4แล้วฮะนะครับ
ได้ครับ
ถ้าอย่างนั้น
ครับผม
ครับ
ขอบคุณครับ
จ้าครับแล้วชยกิจอยู่กลุ่มไหนครับ
ชยกฤต
ที่เข้ามาทีหลังอะครับ
ชยกฤต เดี๋ยวนะฮะ
อยู่กลุ่ม
สอง
4ป่ะคะ
2ครับชยกฤต 2 เอ๊ะ
มีชัยกิจซ้ำปะ
ไม่ใช่ชยกฤตทำไมมี 2 คน
อ้าว
อ๋อโอเค ผมรันตัวเลขผิดถูกแล้วล่ะ แต่ว่าชื่อเนี่ยมันผิดเฉยๆ เพราะฉะนั้นชยกฤตเนี่ยจะต้องโดนลบ เป็นสุกฤตเข้ามาแทนเป็นเบอร์ 26 นี่แทน ส่วน number 26 supposed to be 1 นะ number 25 supposed to be สุกฤตนะครับนะฮะ
โอเคครับ
Okay, so this one is supposed to be a Sukrit, not Chayakrit. Chayakrit should be here.
ได้ครับอาจารย์
ครับ Okay. Any other question? No. So you have to prepare the report. The contents of the report are just the same as the last week reports. So for the last week report, you all have already submitted, right? Okay, I will just check again.
ของผมส่งไปกับอีเมลอะครับที่แจ้งไป ครับผม
ครับ So let's have a look the first group. จุลจิตนี่ไม่ได้ส่งเข้ามาหรือจุลจิตกับกันพิเศษนี่ไม่ได้ส่งเข้ามาใช่ไหมฮะ
ผมส่งไปแล้วนะครับอาจารย์
เหรอ อ๋อ
ผมแนบไฟล์ไปแล้วอะครับอาจารย์
Okay, so based on these results, what you have got from the analysis? อันนี้ของใครเนี่ย จุลจิตใช่ไหมฮะ
เนี่ยอาจารย์ผมส่งแต่ว่ามันไม่ขึ้นว่าส่งนะครับ
Isn't it possible you submitted after 4:30? No, because after 4:30 you are not allowed to submit it. แสดงว่า
ถ้ามันส่งเลทมันต้องขึ้นว่าเทิร์นเลทป่ะครับอาจารย์ใน Microsoft Teams
นั่นแหละสิแต่ว่าไอ้นี่มันขึ้นว่าเป็นมันขึ้นว่าเป็นอะไรนะเมื่อกี้นี้วิวเฉยๆแต่ว่าไม่ได้ turn in
มันต้องกดใส่ไฟล์แล้วก็กด turn in นะครับ
อ๋อแสดงว่าจุลจิตไม่ได้ turn in นะสิส่งเฉยๆใช่ไหม
สงสัยจะไม่ได้กด turn in ครับ เป็นอะไรครับอาจารย์
ไม่เป็นไรฮะไม่เป็นไร
อาจารย์ดูได้อยู่ใช่ไหมครับ
มันมีไฟล์อยู่ในนี้อยู่ฮะ
ครับ
Okay. So what you have got it from the results? So can you just briefly explain it? So ใครดีศิลาอ่ะนะฮะ What you have got it from this results? Can you just summarize it and explain it? ศิลาอยู่ไหมเนี่ยใช่ไหมฮะศิลาหรือเปล่าศิลาหายไปไหน
เดี๋ยวตามเพื่อนให้ครับ
The wastewater the pH is a 6.5 54 dilution factor is 2 this is not the way you you present the results because for the dilution factor 2 so it's the dilution factors of what dilution factor to the colors analysis or the dilution factors for the turbidity analysis the results presentations you have to make something changes in here because it's mixed up. I think the dilution factors is just only for the true color. And one more thing, you should actually present the raw data as well because the raw data, I mean, it gives you some, you know, so that I know it, how do you obtain the data. For example, it's the true color. So when you measure colors and you get like a 350, so 350 and the dilution factors is 2. That is why you get the true color 700 units. That makes sense. But what is it? This dilution factor doesn't mean anything. Conductivity again. So this is multiplied by 10. I suppose this is 10 times to the actual value. So the actual value you get 60 or you get 600. So sometimes you should present the raw data. So you put the raw data somewhere. You can combine the table. I'm talking about this lab, not other lab. Raw data appears here, color, but actually this should be part of the, it should be presented somewhere in the table. Tapped water. Did you compare with the standard? But somehow you have just only report the value. Results presentation, results explanations. Here, they are not the discussion. So discussion must be something meaningful. So you have to change the way to discuss the results. So you should make a comparison to the standard, or somehow you may look for other typical value. For example, for the surface water, in the case of the surface water, you are getting the turbidity as high as 42.6. So you have to check again whether this is too high or too low as compared to the natural water characteristic or natural river. So it may be high or it may be too, because there is no standard in this case. Conclusion. Conclusion is actually with respect to, should be with respect to the objectives. Although in this reports, you're not supposed to write the conclusion, to write the objectives, but conclusion should be with respect to objectives. I suppose you already have the objectives in mind, but there should be some results mentioned in the conclusion. At least you should say like a, what the tapped water according to the the value you have got from the analysis. You can say that this tapped water is safe for drinking So it should be something like that. So, but I'm not sure if you write like we learn about the main properties pH. So is there any objectives relevant to this conclusion? So basically you should write the conclusion with respect to the objectives only, not write in general. The results and discussions, as I mentioned, results presentations is difficult to follow. Even you only have one sample for each types of water. But just imagine if you have 20 samples, so how would you present the results? So if you are doing in this way, then so I just have a look again. Another group 2 Laxica อยู่ไหมฮะ Laxica, I think your file has some problems. So next time, please submit the files with the PDF formats, not the document, not the Microsoft Word formats.
ได้ค่ะอาจารย์
Reset again อันนี้ส่งอีกทีเพราะว่ามันเปิดไม่ได้เข้าใจว่า
ได้ค่ะอาจารย์
เดี๋ยวนะฮะคนอื่นสิทธิพลสิทธิพลมี2 คนหรือเปล่าในห้องนี้มีใครมีชื่อซ้ำกันไหมฮะ
ผมสิทธิพลคนเดียวครับไม่มีนะครับ
เหรอ
ใช่ครับ
เพราะว่าวันก่อนผมสอนคลาสอะไรก็ไม่รู้นะฮะมีชื่อซ้ำกันอยู่3 คู่นะฮะแล้วชื่อนี่ไม่ใช่สมชายอะไรอย่างเงี้ยนะฮะชื่อแบบพิเศษทั้งนั้นเลยนะฮะนัดดนัยอย่างเงี้ยยังมีคนซ้ำเลยนะฮะแล้วก็อะไรอย่างนี้แหละประมาณสิทธิพลอะไรก็ไม่รู้นี่แหละนะฮะมีชื่อซ้ำกันนะฮะทัชพลเนี่ยมี2 คนนะฮะชื่อแบบแปลกๆคือไม่ใช่ชื่อแปลกแต่ว่าไม่ใช่ชื่อที่ควรจะเป็นชื่อโหลนะฮะโอเค so what you have got it from the results from the labs
ก็ได้จากผลแลบที่อาจารย์ให้มาแล้วผมก็เอาไป discussion เกี่ยวกับว่าได้อะไรมาแล้วอีกอย่างก็คือเอาไป compare กับPCD อะครับว่ามันเกินหรือว่ามันเกินมาตรฐานหรือว่ามันต่ำกว่ามาตรฐานแล้วก็
เวลาพูดเดี๋ยวถ้าพูดยาวๆช่วยเปิดกล้องให้ดูหน่อยนะ
ได้ครับอาจารย์ครับ
ยังไงต่อฮะโอเค
ก็ผมเอาผลที่ได้มา compare กับpollutant control department ครับว่ามันต่ำหรือว่ามันสูงกว่าค่ามาตรฐานที่อาจารย์พูดมาแล้วก็พูดว่ามันเกี่ยวกับเขาเรียกว่าอะไรมันมีผลต่อคนใช้หรือเปล่าที่อาจารย์ไกด์มาใน discussion ไกด์ครับครับ
But the problem is in the wastewater sample. Wastewater sample normally we don't measure the turbidity. So if there is results, so do you have any comments?
ก็คือผมคอมเมนต์ข้างใน result ของ wastewater ว่ามันcompare turbidity ไม่ได้เพราะว่ามันมากกว่าคือเอาง่ายๆว่ามันมี solid มากกว่าครับที่อาจารย์พูดในคลิปแล้วผมก็ไปดูตามตารางมันก็ไม่มีturbidity
no standards
ใช่ครับผมจดไว้อยู่ครับแล้วก็ surface water ก็ไม่มีturbidity มันจะมีเฉพาะ
surface water
ใช่ครับ
ครับ but turbidity as I mentioned so you can you can have a look at the pollution control department's website. So you just go visit the page that shows the maps, and then within the maps there is a monitoring stations. You can get some idea about the turbidities from directly from that stations, and then you can compare something. Maybe in the future you can do it in that way
ครับ
แล้วก็ conductivity 500 is already multiplied by 10 or
ครับ already ครับผมเรียบร้อยแล้วครับ แต่ผมแค่เขียนบอกว่ามันมาจากการที่คูณ10นี่แหละผมก็เลยใช้500ลงไปเลย
and ไอ้ color นี่เป็น true color หรือ apparent color
ผมเขียนเป็น true color อาจารย์ไม่เขียน apparent color มาป่ะครับมันเป็นแค่ read from instrument ผมก็เลยงงว่าคืออะไร
ถ้า read from instrument โดยทั่วไปจะเป็น apparent color ไม่ใช่ true color นะฮะถ้าไม่ได้ mention อะไรเนี่ย in general เนี่ยนะถ้าว่า color นี่คือ apparent color หมดเลยนะครับ
ก็ผมเอามาคูณกับ dilution factor มันก็เลยเป็น true color อาจารย์
but how did you get the dilution factor 0.5 so what is the information
result ครับที่อาจารย์ให้ผม
มันเขียนว่าไง dilution factor
0.5 อาจารย์
0.5 เหรอ
ใช่ครับ in color ครับใช่
okay but normally we don't put like a 0.5 0.5 is something I think it should be 1.2 sorry 1:2 so I mean sample one portion and then distilled water another portion so if you do it like this so whatever the value you have rated from the instrument it's supposed to be 2 units so the apparent color should be 4 units but I think maybe there is some misunderstanding but anyway it's okay
ก็เดี๋ยวรอบหน้าผมแปะไอ้ result lab ของอาจารย์เข้ามาด้วยแล้วกันล่ะครับจะได้อาจารย์จะได้ compare ถูกว่าโอเคมันมาจากตรงไหน
หรือไม่ก็ทำอีกตารางหนึ่งเป็น raw data ตะขาบออกมามันจะได้เห็นว่า
ได้
จะดีกว่านะฮะ
ได้ครับ
conductivity according to the conductivity value so all 3 samples you have got 630 700 and 500 right so these are the fresh water or salt water fresh water or salt water sea water
ตอบไม่ได้
Do you have any เหรอ
แต่ผมตอบแค่ว่า waste water มันมี conductivity มากกว่าอาจารย์เพราะว่ามันน่าจะนำไฟฟ้าได้มากกว่ามันมีพวกสารนู่นนี่นั่นอยู่ใน waste water ป่ะ
ทีนี้okay maybe you can just have a look at the teams again
ผมปิดกล้องได้ยังครับ
โอเคเดี๋ยวนะปิดได้เลยอันนี้คุณนอนเรียนหรืออะไรยังไงเนี่ย
แค่ NA นะอาจารย์
เดี๋ยวนะอันนี้นะฮะin a forest ไม่ใช่ in a background you will find some information and then if you have a look at the link the useful link you could find like a ไปไหนละ lab 1 supposed to be this one this is not the updated one colors and conductivity I think this is the updated one I have put some photographs so that you can see for conductivity okay this is the conductivity in here so if you really goes into this website you will find that deionized water or the pure water, the conductivity generally allow 5.5 microsiemens per centimeter at 25 degrees Celsius. But the seawater, this value it goes up to 50,000 microsiemens per centimeter. 50,000. Okay, 50,000. So salt water or seawater, you should get like a 50,000, but in here you get like a 600, 500. So it's still fresh water, not the seawater. Even wastewater still contains very less conductivity as compared to the seawater. But anyway, it's slightly higher than the tapped water. But you shouldn't expect like the tapped water should be the conductivity will be much smaller than the wastewater. So if the tapped water contains lots of minerals, like mineral waters, conductivity is also higher, but not as high as the seawater. Okay. Okay. What about other groups?
อาจารย์ครับ
ครับ
แล้วอย่างนี้คือผมต้องคอมเพลใช่ไหมว่าแบบว่ามันนำไฟฟ้าได้ดีไหมอะไรอย่างนี้หรือว่าผมต้องแบบว่า
ไม่conductivity เนี่ยเราไม่ได้ดูว่ามันจะนำไฟฟ้าได้ดีไหมแต่ว่าเอาไว้เป็นอินดิเคเตอร์ถึงการปนเปื้อนของ source contents มากกว่านะฮะคือเราไม่ได้สนใจว่ามันนำไฟฟ้าดีไม่ดีนะฮะแต่ว่าไอ้ตรงนี้มันเป็นอินดิเคเตอร์ที่บอกในทางอ้อมเฉยๆว่ามันมีสิ่งเจือปนกี่มากน้อยโดยเฉพาะในกลุ่มของไอออนนะฮะ
โอเคครับอาจารย์
ทีนี้ถัดไปอันที่3นี่ดานุภพนี่คนไหนเนี่ยดานุภพนี่อยู่ในนี้ป่ะอ้าวไม่ใช่okay. So I have already shown you. So this is another session's result. So they have put it like this. This is interesting. This is how they make a table, you see. So maybe next time you can try. So this one is easy. So whenever you visit the PCD's website, the parameters is always put it in the far left column, and then the units is the next. Then the values should be shown in the far right columns. This is another way of the results presentation. So which one is better as compared with the previous results report? So which one is better in your opinion? So just have a look again. So this one is for the wastewater sample, and another one is the tapped water sample. So this is another way of the results presentations. Okay. Thenเดี๋ยวนะฮะ
อาจารย์ครับ
ครับ
แล้วงี้lab 2มันไม่มีมาตรฐานที่เป็นแบบ department แล้วก็เอามาตรฐานแค่ที่อาจารย์บอกใช่ไหมครับว่าวัดแบบได้เท่าไหร่ละ
ใช่ typical value อะไรประมาณอย่างเงี้ย
โอเคได้ครับ
จะเป็นลักษณะแบบนั้นแทนอันนี้3นะฮะวาริสาใช่ไหมวาริสาอยู่ไหนเอ่ย
แป๊บนึงนะคะวริศรากำลังเข้าห้องน้ำอยู่อะค่ะ
วริศราเหรอฮะ but who are with us hereคุณรู้ได้ไงเขาคุณออนไลน์ด้วยกันเหรอ
สวัสดีค่ะ
ครับ okay so what you have gotten from the analysis this is another way of the results presentation You see, how many style you have seen it?
อันนี้ของหนูค่ะ
Okay, please go ahead. ว่าไง
tap water ไม่สามารถใช้ในการบริโภคได้
Why?
because conductivity มันเกินค่าที่เขากำหนด
Are you sure?
I'm not sure.
As far as I understand, there is no such the recommendations or the guidelines governing the conductivity value. Just check again.
No
Okay, what else?
Okay. Surface water ก็น่าจะเป็น fresh water ซึ่ง
Surface water would definitely be the fresh water because these samples I have collected from the ponds in front of our building.
Okay. Which I think it's not suitable for aquatic life.
Really? But so many aquatic life live in that ponds. It's against your belief.
Because I've found out that the conductivity should be around 150 to 500, but it gives 550.
Conductivity. There is no, there is no informations or the standards govern about the conductivity. Conductivity can be vary, so you cannot say like it is too high or it is too low. But if you compare with other sources of the fresh water, it may be high, it may be low. So if you compare it like this, it is okay. But you cannot say this is too high or this is too low.
หมายถึงว่า it's ideal water conductivity for fish to live in, not
Fish?
the standard. Yeah.
Fish, they can actually live it in various length, in a very wide length of the conductivity.
Okay.
Some fish in the sea water, the conductivity is 50,000. So other types of the aquatic organisms, they can still survive with that high, such a very high conductivity. So maybe this may not be possible. This may not be a good discussion. I'm talking about the concerning the conductivity with the conditions for the aquatic organisms. So maybe there are some other points, but you can you compare with other sources. That would be better if you want to discuss the conductivity. And what else? I have seen the temperature. Temperature seems to be very high at 46 degrees Celsius in the Japanese onsens. So what is the normal temperatures they maintain it? Have you ever been to Japan? And then we have one student.
41 to 42.
41 to 42. But this one is already 36. It's warm water. 41 or 42, that's very hot, right?
It's not that hot.
Oh, really? But do you have like a onsen in your house? In Thailand, as far as I know, we don't have. มีหรือเปล่า
onsen จริงๆแล้วมันเกี่ยวข้องกับน้ำอะค่ะ it depends on what kind of water you're using. If it's just a normal bathtub, we still have the temperature where we can set it. But if it's onsen, it means that the water itself is actually it contains minerals. It depends on the province.
So it's natural waters, like onsen is basically natural waters, not the hot water and put some salts or some minerals inside. Okay, then what else that that could be interesting? No. Dilution factor is only applied to the color measurements, right? Okay. No other parameters. Okay, so I will have a look for the discussions in the report again. Okay, then the last group.อันนี้ของใครเอ่ยพจน์นี่คนไหนอ่ะพจน์นี่อยู่ไหมฮะ
ฮัลโหลครับอยู่ครับ
So based on your results, can you just tell us what you have achieved?
ครับ หมายถึงให้อธิบายว่าobjective ของผมคืออะไรนะครับ
What kind of samples you have analyzed, and then based on the results you obtained, what conclusion can be drawn? Okay, based on your objectives.
คืออย่างที่ผมทำเนี่ย
เดี๋ยวนะอันนี้เนี่ย color เนี่ย unit is units not milligrams per liter. In fact, the colors we use the platinum cobalt method. So 1 milligrams platinum cobalt in 1 liter will give the colors 1 unit. So 5 milligrams is 5 units. So the units you have got from the instrument, it should be unit, not milligrams per liter. So maybe you can correct this one later.
แล้วอันนี้ต้องไปส่งใหม่ไหมครับเนี่ย
ไม่ต้องละครับว่ามาเลย
ก็จาก result นะครับมันก็
พจน์นี่คนไหนเปิดกล้องให้ดูหน่อยดิ
เดี๋ยวนะครับ
เวลาพูดเนี่ยนะฮะyou need to show up your face presentation นะฮะ
โอเคเดี๋ยวขอดูที่ผมจาก result อาจารย์เปิดหน้าของผมนะครับเมื่อกี้ครับ
วันนี้ไม่ใช่หน้าเราเลยอ๋อ
ไม่หมายถึง
โทษที
ไอ้รีพอร์ตที่ผมส่งครับใช่ครับคือเมื่อกี้ผมไม่แน่ใจว่าเสียไปก็จาก result ที่ได้มาผมต้องการจะหาแบบว่าในพารามิเตอร์ทั้ง5อย่างที่กำหนดมาเนี่ยครับอันไหนมันจะบอกไงอันไหนมันได้ค่ามากที่สุดเปรียบเทียบ compare กับใน sample ทั้ง3ตัวนะครับของ tap water surface water แล้วก็ waste water ซึ่งจากค่าที่ได้มาก็รู้ว่าไอตัวwaste water เนี่ยมันสามารถนำไฟฟ้าได้ดีที่สุดนะครับครับแล้วก็อย่างนะครับจากอันนี้คือ objective ผมอยากรู้ว่าไหนมันมากที่สุดนะครับผมไม่ได้ไป compare กับ standard ที่อาจารย์ที่กลุ่มอื่นเขาพูดนะครับ
okay so you compare it among these pre-samples only but doesn't remark it if you compare among these 3 samples you cannot compare the tapped water with the surface water. You cannot compare a wastewater with the tapped water. And if you say like the wastewater contains color 250, and this one is higher than the tap water, the colors of the tap water, you cannot compare in this way because there are different types of sample. The wastewater, it's of course it's dirty, so the color is high. We know that. So we shouldn't compare like a wastewater with the tap water, and then we shouldn't come up with the conclusion like a tap water has got better quality, water quality, because of course if they are the tap water, if the quality is not good, then we will not consume. So if you want to compare, maybe you should compare like if you have two tapped water sample. So you compare a tapped water collected from the source number 1 with the source number 2, that is okay. For wastewater, you can compare like the wastewater collected from the first source, from this industry and other industry. BOD you obtained from this industry is high, then BOD obtained from the second industry is low, so that is comparable. But surface water should not be compared with the wastewater. Wastewater shouldn't be compared with the tap water นะฮะมันคนละเหมือนมันคนละดิวิชั่นกันนะฮะเหมือนคุณดูฟุตบอลน่ะนะอันนี้เป็นแบบระดับจังหวัดอันนั้นมันระดับชาติอะไรเงี้ยมันคนละไอ้นี่กันเราจะบอกว่าระดับชาติเขาเล่นฟุตบอลเก่งกว่าระดับจังหวัดมันก็แน่นอนอยู่แล้วใช่ไหมยกเว้นว่าเราเปรียบเทียบกันในทีมระหว่างลีกเดียวกันแบบเนี้ยอันนั้นน่ะได้นะฮะยังไงต่อ
แค่นี้แหละครับโหนะคือผมคอมเพลระหว่างแซมเปิลที่อาจารย์ให้มา
คือถ้ามันเป็นแซมเปิลประเภทเดียวกันอันนี้เราเปรียบเทียบกันได้แต่ว่าถ้ามันเป็นคนละประเภทเนี่ยนะฮะก็อาจจะต้องระวังนิดนึงอย่าง surface water เนี่ยมันอาจจะเทียบเคียงกับ tap water ได้เพราะว่า surface water เนี่ยเป็นwater supply source we use the surface water to produce the tap water. You may compare in some way, in some aspect, but wastewater you shouldn't compare with the tap water. It's completely different. แล้วก็อะไรฮะเนี่ยอันนี้คือก็มี color ที่อาจจะต้องปรับนิดนึงแล้วก็wastewater นะฮะอันเนี้ยต้อง observe นิดนึงว่าwastewater normally we don't measure the turbidity because it's doesn't has any meanings but it gives the results that I have given to you contains this number. Maybe you can just report it, but it is not. It doesn't has any meaning to the wastewater. Wastewater normally we measure in terms of the suspended solids, not the turbidity. มีอย่างอื่นอีกไหม
ไม่นะครับ
นะฮะแล้วของคนอื่นนี่เหมือนกันหรือเปล่าในกลุ่มเนี่ยนะฮะเหมือนกันไหมฮะ
ไม่เหมือนครับไม่ได้เราน่าจะตั้งคนละ objective กันนะครับ
ขอดูของคนอื่นบ้างเมื่อกี้เราเห็น3-4หลายคนเห็น3-4 สไตล์นะไอการเขียนอะไรนะpresent results เนี่ยนะฮะตอนนี้ก็จะเห็นว่าอันไหนดูง่ายอันไหนดูยากนะ
อย่างผมเมื่อกี้นี่ดูง่ายนะครับแต่ผมว่าจะดูแบบตารางเล็กๆดีนะครับ
อันไหนนะเมื่อกี้เหรอ
ใช่ครับผมก็แตะสั้น
ๆคือจริงๆเนี่ยให้ดีเนี่ยคอนเซปต์เนี่ยคือควรจะเอามารวมกันไม่ต้องแยกตารางจริงๆแล้วอะนะฮะเพียงแต่ว่าphysical characteristic เนี่ยนะฮะอาจจะตามความเห็นผมนะแต่ว่าอันนี้ก็ไม่ใช่ว่าmust นะคือphysical characteristic เนี่ย should be second to the samples title คือไอเนี้ยควรจะอยู่คอลัมน์ที่2นะเพราะว่า อันนี้มันเป็นแบบเรื่องทั่วไปแล้วก็pH turbidity conductivity แล้วก็ colors เนี่ยโอเคนะครับโดยส่วนใหญ่เนี่ยเขาจะเรียงตามตารางที่มันอยู่ในมาตรฐานหรือบางทีเนี่ยมันอาจจะมีคือบางทีเนี่ยถ้าเกิดว่าเราจะบอกว่ามาตรฐานของ pH เท่าไหร่ turbidity เท่าไหร่ conductivity เท่าไหร่ก็น่าจะมีอยู่ในตารางนี้ด้วยมันก็จะทำให้เห็นเปรียบเทียบได้ดีขึ้นนะฮะอันนี้ก็แต่ทีนี้ถ้าเราบอกว่ามาตรฐานเราจะใส่ตรงไหนถ้าสมมติว่าเราจะบอกมาตรฐานเราจะใส่ยังไงดีตารางนี้เนี่ยนะฮะเราจะ revise ยังไงดี
อาจจะแบบใส่เพิ่มข้างล่างอะไรอย่างเงี้ยครับข้างล่างตารางเพิ่มไปอีกเพิ่มโลอีกอันหนึ่งใส่มาตรฐานไว้
แต่ว่าbelow เนี่ยนะฮะอย่าลืมนะว่าน้ำเสียมันก็น้ำตัวอย่างมันก็เป็นคนละประเภทมาตรฐานมันก็เป็นคนละตัวกันอันนี้ก็เป็นศิลปะอย่างหนึ่งในการดีไซน์ตารางนะครับก็ลองดูนะฮะก็ไม่เป็นไรอันนี้ก็ค่อยๆดูไปเผื่อวันหน้าวันหลังจะเกิดไอเดียอะไรเพิ่มเติมเดี๋ยวนะผมให้ดูหลายๆอันนะครับconductivity เนี่ยthe first labs เนี่ยของอันอื่นเป็นไงบ้างอันนี้ดิวไปแล้ว seconds ไม่ใช่นี่ใช่ไหมเมื่อกี้อะไรนะสิทธิประกรณ์หรือว่าอะไรนะสินอะไรนะชื่ออะไรนะ
สิทธิพลครับ
สิทธิพลอ๋อโอเคสงสัยสิทธิประกรณ์นะมั้งที่ชื่อซ้ำมาเนี่ย
อ๋อครับ
อันนี้ก็เป็นอีกอันหนึ่งนะฮะแต่ว่าอันนี้จะไม่มีอันนี้จะมีเขาจะมีเขาเรียกอะไรนะstandard นะฮะเพิ่มเติมลงมาข้างล่างนะครับก็น่าสนใจก็ทำให้เราได้มีอะไรเป็น reference นะครับเนี่ยเวลาเราไปเขียน project report หรืออะไรก็แล้วแต่นะครับก็จะเป็นลักษณะแบบนี้แหละนะฮะเราจะไม่ discuss โดยที่มันเป็นทั่วๆไปนะครับนะฮะปีต่อไปไปเขียนreport อะไรนี่ก็อาจจะต้องคล้ายๆอย่างที่ผมบอกเนี่ยนะครับวิธีการหรือว่าไอเดียที่จะเอามาเพิ่มเติมในการเขียนนะครับ another group this one may be similar to some of your friends ครับโอเคนะฮะมีใครมีคำถามหรือว่าอะไรเพิ่มเติมไหมฮะ
อาจารย์ครับแล้วครั้งหน้าสมมติว่ามันมีมาตรฐานเนี่ยผมแปะแค่มาตรฐานลงได้ไหมไม่ต้องทำตารางเลย
ก็เป็นไปได้แต่ว่ามันมาตรฐานเราไม่ได้ใช้ทุกตัวนะฮะก็ไม่รู้ก็ลองดูนะฮะครับนะฮะแต่ว่ามาตรฐานนี่มันไม่ใช่สูตรสำเร็จในการอภิปรายนะอภิปรายเนี่ยมันมีอย่างอื่นอีกเยอะแยะมากมาย